Hello Year 8. Today we're doing area of sectors and composite figures. So last lesson we looked at area of circles and half circles and quarter circles, but a sector is any wedge of a circle that we want to find the area of. So the center of the circle would always be at this point here, and we're trying to find any different sized wedge. So to do that, we need to know the angle that is made at the center of that sector there. Now, to give that a name, we use another Greek letter, which is the letter theta. Now, to draw a theta, it's like drawing a zero, but you do an extra little loop around the middle. Okay, so you go around and around again. So theta. So that theta just represents the size of the angle that we have cut out for our sector here, which is like a piece of pizza. Then we times that by the area of a circle, which is pi r squared. Okay, so the formula is for a sector theta over 360. So that's the fraction of the circle that we have. And then we times that by pi r squared. Now we could also do this as composite shapes, where we might have part of a circle. So this one has half a circle combined with a triangle, or it could be any of the other shapes that we have learned how to find the area of as well. We can also find the area of what is called an annulus. Now an annulus is two circles that have the same center, and you want to find the area between the two circles. So what you do is you find the area of the big circle. So because we have two different radiuses, we call the big circle capital R and the little circle little r for radius. So the area is pi r squared of the big circle and subtract off pi r squared for the little circle. Or you could factorize that formula to be this one here below. So either version of that formula to find the area of an annulus. Okay, so let's have a look at some questions. Question number 1, find the area of the following sectors correct to 2 decimal places. So to find the area of a sector, our formula is theta over 360 times by pi r squared. So that's my area of a circle formula there. So substituting in, the theta is just the angle that we're given for our sector, which in this case is 60 degrees. So 60 over 360 times by pi times the radius, which is 8 centimeters. Type that into your calculator. So we have 60 over 360 times by pi times by 8 squared. So to 2 decimal places, that'll be 33.51. And that will be centimeters squared. Part B, finding the area of that sector. The formula is theta over 360 times by pi r squared. So the theta is the angle, which is 41 degrees this time, over 360 times by pi times the radius, which is 12 squared. And type it in. So 41 over 360 times pi times 12 squared, which is 51.52. centimeters squared. And one more of these, part C, to find the area of the sector, we want the angle over 360 times by pi r squared. So practice writing the formulas over and over so that you can memorize them. Substituting in, the theta this time is a very big angle, 310 degrees, over the 360 times pi times the radius, which is 2 squared. So through 310 over 360 times pi times 2 squared is 10.82 centimeters squared. Question 2. Find the area that is used by the windscreen wiper blades shown in the diagram below. Give your answer correct to 2 decimal places. Okay, so we're wanting to find the area of the sector. So the formula is theta over 360 times by pi r squared. So the theta is 100 over 360 times by pi times by 1.2 is the radius squared. Type it all in and we get 1.26 meters squared. Okay, so that was the area in this sector here. But part B says, what is the area of the windscreen that is not cleaned? So I'm trying to find now this area out here that has not been cleaned. So that is the area of the rectangle taking away the bit that was cleaned. So the area of a rectangle is length times breadth. And then I want to take away the area of my sector. Now I don't want to have to calculate that again. I already know that that's 1.26. Now subbing in for the area of my rectangle, the length of my rectangle is 2 and the breadth is 1.5, and subtract off my sector. So on the calculator, 2 times 1.5 minus the 1.26 is 1.74 meters squared that had not been cleaned. All right, that's the end of that question. Question 3 is to find the area of each annulus. So the formula that I'm going to use is A for area equals pi bracket big radius squared minus little radius squared. Okay, so the problem is that I haven't been given the radius in this question. I've been given the diameter. So this 72 is for my big circle. If I divide that by 2, then my big radius would be 36. The 45, that's the diameter of my little circle. So that would be little r, if I divide that by 2, will be 22.5 millimeters. Okay, so they're the numbers I need to substitute in. So the area of my annulus is pi bracket big R, which is 36 squared, minus little r, 22.5 squared, close bracket. And we put that in the calculator. So pi times 36 squared minus 22.5 squared to 2 decimal places is 2481.07. And that is in millimeters, so millimeters squared. Part B is probably easier, but because these measurements here are, this would be by capital R and this one will be my little r. So I can put these numbers straight into the formula. So the area of an annulus is pi bracket capital R squared minus little r squared. So pi bracket capital R is 18 squared minus little r, which is 9 squared. And type it in. 18 squared minus 9 squared. So 763.41. And that is centimeters squared. Okay, on the next page, we now get to our composite shapes. So in part A, imagine if I draw a line across here, I have got half of a circle on the top and a rectangle on the bottom. So I need to find the area of both of those parts. So let's start with the formulas. The area of half of a circle, because it's half a circle, I need the half, and the formula for a circle is pi r squared for area. Then I'm going to need to add to that the area of a rectangle, which is the length times the breadth. Substituting in on the second line, the radius of my circle, this 55, would actually be the diameter. So the radius would be half of that, which would be 27.5. So half times pi times 27.5 squared. That's the area of my half a circle. Plus, now for my rectangle, the base or the length times the breadth, which is 25. Again, the brackets are just there so that I can see there is my half a circle, there is my rectangle. So typing that in, we get half times pi times 27.5 squared plus 55 times 25 is 2562.91, and that'd be meters squared. Okay, part B. We have got half of a circle here on the top. So again, we're going to need the half of pi r squared, half of a circle. Plus this time on the bottom here, we have a triangle. So the formula for a triangle is half the base times the height. So there's my two shapes. Substituting in for my circle, the radius. Now that's a bit tricky because I don't actually have a radius or a diameter. So I actually need to do a Pythagoras' theorem to find the h in that right angle triangle, to find the hypotenuse. So over here on the side, to find the hypotenuse, we have the formula square root of a squared plus b squared. So the hypotenuse, the a and the b is the 8 and the 4. So 8 squared plus 4 squared. And that is going to be equal to big square root sign, 8 squared plus 4 squared, 8.94. Okay, so that's the whole diameter. Then I would need to divide that by 2, which should be 4.47 for the radius. Okay, so finally we can substitute that into this formula. Half times pi times the radius, which is 4.47 squared, plus, okay, that's my half circle, plus my triangle, which is half times the base and the height of my triangle are the ones either side of this right angle, so the 4 and the 8. So half times 4 times 8. And calculate. So half times pi times 4.47 squared plus half times 4 times 8. It's 47.39 centimeters squared. And question 5. Calculate the shaded area. Now what I have here is a square with 4 little circles cut out. All 4 of those circles are the same size. So to find the area, I would need to find the area of the square, which the formula for a square is s squared. And then I want to take away the 4 circles. So 4, and the formula for a circle is pi r squared. Okay, let's substitute into that. Now, the side of the square is 7 meters, so that will be 7 squared. Take away 4 lots of pi times the radius. Now, be careful here, that 2.3 is a diameter, so we need to go 2.3 divided by 2. So the radius is 1.15. Now, to find, so put that in the formula, sorry. So 4 times pi times 1.15 squared for the radius. And calculate. So 7 squared minus 4 circles, pi times 1.15 squared is 32.38. And the units were meters squared. Okay, and that's it.